We can use Pascal's triangle to expand a plus b to the n power. A plus b is binomial. Right? To expand powers of binomial, we can use Pascal's triangle. All right, so when n equals 0, we can make a plus b to the 0 power. As you know, any number's 0 power is just 1. So in Pascal's triangle at the top, we use 1. N equals 1, a plus b to the 1 power. So if you expand it, it's going to be a plus b. In Pascal's triangle, we use coefficient of terms. Coefficients are the numbers right before the variables. So 1 and 1. In Pascal's triangle, we put 1 and 1. When n equals 2, we can make a plus b to the second power, which is a squared plus 2ab plus b squared. So coefficients are 1, 2, 1. You put 1, 2, 1. Right? After 2, I'm not going to expand a plus b to the third power. If there is 3 in the exponent, we're going to have 1, 2, 3, 4 forms. 4 terms. In the expanded form, we have 1, 2, 3, 4 terms. So in Pascal's triangle, we should make 4 numbers. 1, 3, 3, 1. How did I get these numbers? In each end of Pascal's triangle, we use only 1. 3 is sum of these two. This 3 is sum of these two numbers. So we can guess next numbers. When n equals 4, which means a plus b to the fourth power, there should be 1, 2, 3, 4, 5 terms. Number of terms in expanded form is 1 greater than n. So because n is 4, there should be 5 terms. So there should be 5 numbers in the Pascal's triangle. In each end of Pascal's triangle, we put 1. Sum of these two numbers, 4. Sum of these two numbers, 6. Sum of these two numbers, 4. 1, 4, 6, 4, 1. All right. N equals 5. A plus b to the fifth power. There should be 6 numbers. So in Pascal's triangle, we put 1 in each end. Sum of these two, 5. Sum of these two, 10. Sum of these two, 10. Sum of these two, 5. We can keep on going. Okay? All right. By using Pascal's triangle, let's expand this one. A plus b to the third power. From Pascal's triangle, when n equals 3, from Pascal's triangle, we got 1, 3, 3, 1, right? You put 1, 3, 3, 1. And then this is how you expand it. First term in this binomial, first term is a, second term is b. So you start from first term a's a with the highest power, 3. After first term, the degree of first term a is decreasing. So a to the third power, a to the second power, a to the 1 power, a to the 0 power. But second term b start with 0, b to the 0 power, but the exponent, the powers of b, second term b should be increasing from first term. Because first term was b to the 0 power, second term is b to the 1 power, b to the second power, b to the third power. And then to connect two consecutive terms, you always use addition. Okay? B to the 0 power is 1, so 1 times a cubed times 1 is a cubed, plus 3a squared b1, b1 is just b, plus 3ab squared, plus a to the 0 power is just 1. So 1 times b cubed is b cubed. This is how you simplify, how you expand binomial by using Pascal's triangle. All right, let's try next question. X plus 4 to the fourth power Let me erase this part. The question is x plus 4 to the 4th power. Because n is 4, we're going to use these 5 numbers from Pascal's triangle. 1, 4, 6, 4, 1. 1, 4, 6, 4, 1. Between two consecutive coefficients, you should make some rooms. All right. First, x to the 4th power. And then degree of first term x is decreasing after first term. So x to the 3rd power, x to the 2nd power, x to the 1 power, x to the 0 power. And then you multiply second term, 4 to the 0 power, start from 0, but the power of 4 should be increasing. So 4 to the 1 power, 4 to the 2nd power, 4 to the 3rd power, 4 to the 4th power, and then simplify. Any number 0 power is 1, 0 power is 1, so x to the 4th power plus 4x, 4 times 4 is 16, so 16x to the 3rd power plus 4 squared is 16, 16 times 6, 96, 96x squared plus 4 to the 3rd power is 64, 64 times 4 is 256, 256x plus 1 times x to the 0 power is 1, 4 to the 4th power is 256. That's answer. Okay. And then we're going to try 2x minus 1 to the 3rd power. If there is negative, you better take this one as 2x plus negative 1 to the 3rd power. And then take parenthesis 2x as a and parenthesis negative 1 as b. So this is a plus b to the 3rd power. Because n is 3, we're going to use these 3 numbers. 1, 3, 3, 1. 1, 3, 3, 1. Okay, and then start with parenthesis 2x. So parenthesis 2x to the 3rd power, parenthesis 2x to the 2nd power, parenthesis 2x to the 1 power, parenthesis 2x to the 0 power. But the powers of negative 1 is increasing, right? So negative 1 to the 0 power, negative 1 to the 1 power, negative 1 to the 2nd power, negative 1 to the 3rd power. And then you always use addition to connect two consecutive terms. All right. Parenthesis negative 1 to 0 power is 1. Parenthesis 2x to the 0 power is also 1. So first term is 2x to the 3rd power. 2 to the 3rd power is 8. X to the 3rd power is x cubed. And then negative 1 to the 1 power is negative 1. And then 2 squared is 4. X squared, x squared. And then times 3. So it's going to be 3 times 4 times negative 1 for coefficient. Negative 12 x squared. And then negative 1 squared is 1. This is just 2x, so 6x. Last one, negative 1 to the 3rd power, which is negative 1. 2x parenthesis 2x to the 0 power is 1. So negative 1. This is answer. All right. I'm going to try 5c. 3x plus 1 to the 4th power. Yeah, you better take 3x as parenthesis 3x, which is a, plus 1 is just b to the 4th power. N is 4, so you're going to use these 5 numbers. 1, 4, 6, 4, 1. 1, 4, 6, 4, 1. Okay, and then you start from parenthesis 3x to the how many power? Fourth power. The power of 3x, parenthesis 3x is decreasing. But power of 1 is increasing. So 1 to the 0 power, 1 to the 1 power, 1 to the second power, 1 to the third power, 1 to the fourth power. Basically, these are all 1. Okay, and then simplify. 1 times parenthesis 3x to the fourth power. 3 to the fourth power is 81. X to the fourth power times 1 is just 1. And then 1 to the 1 power is 1. So you do 3 to the third power, which is 27. 27 times 4 is 108. So 108 x to the third power. And then 1 to the second power is just 1. 3 squared is 9. 9 times 6 is 54x squared. 1 to the third power is just 1. 12x plus last one is just 1. This is